Hello, everyone, and welcome back. Where we've been tackling FRQs to get ready for our CSA AP exam. Today is no different. This one's coming from 2010. Number one, talking about cookie orders. So, an organization raises money by selling boxes of cookies. A cookie order specifies the variety of cookie and the number of boxes ordered. The declaration of the cookie order class is shown below. So we see our class that's going to represent our object, cookie order. And we're taking in a string and an integer. That string represents the variety of cookie, something like chocolate chip. And int is number of boxes. How many did we order? Okay, this is the class that they give us, and you're just to kind of assume it works. Now, because we're actually programming these in IntelliJ, we'll end up writing this out, and it shows that there are some instance variables, constructors, and methods that may not be shown, right? We can kind of deduce, right, because we have a constructor which takes in a string and an integer, that those are going to be our instance variables. They'll be stored privately, a string and an integer, and then we see these two getter methods. That's how we'll be able to access those things. So we'll end up copying and pasting this and actually filling it out, the places where the implementation is not shown. Then we see a completely different class. The master order class maintains a list of the cookies to be purchased. The declaration of the master order class is shown below. We see a list, which again, this was a popular technique on the older FRQs. The only list we know in CSA is array list, so you could just substitute array list here, and it's going to work the exact same for all intents and purposes. So we're going to have an array list of cookie orders, right? That's this object from above. And that is called orders. So they give us this instance variable. That's important because whenever we write these methods for part A and part B, we're probably going to need to refer to the instance variable, and it's important that you note that the instance variable here is called orders. Then there is our constructor, which is a no-args constructor. I can tell it's a constructor because it has parentheses, which looks an awful lot like a method, but there's no return type, not even void. And all we're doing is initializing orders, this instance variable, to an array list, an empty array list. Cool. We see the add order method, which they give us the implementation. All it does is it takes in a cookie order object and tacks it onto our instance variable at the end. Okay, so then we have get total number of boxes, which we're going to end up writing, and then we have remove variety. Why don't we go ahead and get into IntelliJ, and first thing we're going to do is actually implement this cookie order object. So I'm in IntelliJ. I'm going to do a file new project. We'll go next, and this is going to be in 2010, number 1. Going to expand my project folder, right click on the SRC, do a new Java class, and this one's going to be called cookie order. I'm going to paste in their code, which there's not a lot here. We'll end up filling it out. Right? We have our class header. We have our constructor. We have a getter for the variety, a getter or accessor method. And then we have a getter or accessor method for the number of boxes. So the first thing I want to do is actually throw in some instance variables here, some fields, if you're familiar with that word. And I can deduce what they are, again, by looking at our constructor. Again, I can tell it's a constructor because it's parentheses, which looks an awful lot like a method. We're taking in parameters. Again, it looks like a method, except there's no return type. And here we can see that the name matches our class name. So that is a constructor. And the whole purpose of a constructor is to initialize the instance variables. Well, we need some instance variables. So I'm going to create private string variety. I'm going to create private int num boxes. And all this constructor is going to do is take in these parameters, these arguments, and save them into these instance variables, right? And because our instance variables have the same name as our parameters, right, these local variables, I'm going to use this dot notation. I'll say this dot variety is equal to variety. I'm saving in this instance variable, this local parameter into my instance variable. And this dot numBoxes is equal to numBoxes. So there's our constructor. This is a getter method, at least it looks like it, and all it's doing is going to return variety, and then we have get numBoxes, and all it is going to do is return numBoxes. Pretty straightforward, just an object. Really, the whole purpose is to hold these two pieces of data together inside of a cookie order object. Sweet. Let's go ahead and get started on our master order as well, and we'll put that in, start to fill it out a little bit before we actually get to part A. So our master order, I'll paste in the code that they give me. I'm going to have to fill out some parts, I think. Now here, this is red, this is mad because we need to import list. On an actual FRQ, you don't have to import. You assume everything is imported. And we could simply use ArrayList if we wanted to. The newer FRQs are going to refer to ArrayList, which would also need an import. But for all intents and purposes, those are going to be the same thing for us. So then we see our noArgs constructor, which just initializes that instance variable. And lastly, we have add order, which is going to just tack on this cookie order, right? We pass it in. Because this instance variable is inside of the object, and I need to add the cookie order, well, I have to basically go through a public method, and then it's up to this class to take that cookie order and append it to the private instance variable, right? This is going to end up getting used in a separate class, like a driver. And in that class, we won't be able to see this private instance variable orders. What we can see is this public method add order, which would take that cookie order, and it is responsible for actually tacking it onto the end of this private instance variable. Okay, part A, which we're about to get to, we're just going to leave that kind of blank for now. And a lot going on with this one. I want to do that up here for this too. Okay, let's look at part A, then we'll come back and get started on filling this out. So part A, the getTotalBoxes method computes and returns the sum of the number of boxes of all cookie orders. If there are no cookie orders in the master order, the method returns 0. The sum of the number of boxes in the cookie orders. So here's the thing. Our master order contains a lot of cookie orders. They're inside of this list, which is inside of the master order. And what we're trying to do with get total number of boxes is how many total boxes out of all of the orders are there. So what that means is we're going to need to loop through orders, this array list. Now it contains cookie orders. And inside of cookie order is how many boxes pertain to just that cookie order. So our logic here with part A is to loop through all of our orders. Those are cookie orders. We will pull out the number of boxes in each order and then add it to some type of variable. So I'm going to need some type of variable. I'm going to call it count, which represents the total number of boxes. Other like really good variable names is maybe boxes. Okay. Now, because I'm only accessing information, I'm not really modifying things, this is a very good candidate for a for each loop. What we're looping through is orders. It contains cookie orders. So I will say for each cookie order, which I will refer to as, here they're suggesting cookie order. I want to do something different so that you don't confuse the data type with a variable name. So let's go with CO. For each cookie order, which we'll refer to as CO in orders. Right? This is ultimately what we're looping through. Each individual element in that array list is a cookie order. And I'm going to refer to the current cookie order as CO. I want to take CO and I'm going to pull out how many boxes are in it. Right? This is an integer. CO is a cookie order object. I'll take the object, I'm going to pull out the number of boxes. What I have highlighted is an integer. I want to save that back into boxes, but I don't want to lose my old information, so we're going to do a little addition here. So we're going to say boxes plus equals the total number of boxes in this cookie order. Right? We're looping through all of the cookie orders, taking the current one, asking how many boxes do you have? Okay, let's add it to our boxes. This could be expanded to boxes equal to boxes plus co.getNum boxes. Right? These expressions are the exact same thing. Right? Boxes will become what it currently is plus the number of boxes in the current cookie order. So we do that for all of our orders inside of our orders array list. And after the loop is finished, we just return our total, which is boxes. Now, it is possible to get 0, right? And the way our algorithm is currently written, it will do that. We start out with 0, and if we try to loop through orders and there aren't any cookie orders there, we would get back 0. Let's test this out. I'm going to right click on the SRC. Let's make a new Java class called driver. All right. Did they give us an example? Maybe a little bit later. There's part B. They don't even give us an example. We can steal some of this though and figure out from there. We're going to end up using this for part B, so this will be a good candidate for part A as well. So what I'm going to do is create my master order. Is equal to a new master order, right? That's going to start out, there's nothing in it. We need to add to it. So we'll take master, we'll add to the order a new cookie order. Now here, in order to make a cookie order object, we need a string, which represents our variety, followed by an integer, which is how many boxes. If we look back at our example, first thing they have, chocolate chip, and 1. Let's do that. So chocolate chip is our variety. I think I'm going to type that faster than fixing it. Yeah, only 1 chocolate chip. You can do better. So we'll add to our master order a new cookie order object. The variety is chocolate chip, and there's 1 box coming out of that. I'm going to grab this, paste it, because all we got to do is change this stuff here. We have shortbread at 5. I feel like I could probably tab to that or something. We have macaroon at 2. Macaroon. Yep, at 2. And then chocolate chip at 3. So I'm using the example for part B to kind of test part A. Right? First thing I want to see is, are all these things actually getting into my master order? In order to do that, I would want to print off the master order. Now, those of you that have been tuning into these things are going to quickly recognize that this ain't going to give me what I want. Part of the reason is part B has some errors in it, so let's just throw in some nonsensical code here. Run our driver again, and I get this. Right? This is because master order does not have a toString method. So if I flip over here, this is outside of kind of what they're trying to do with this FRQ. But in order for us to demonstrate that this is indeed working, I want to write a toString method. And all I really want to see is the contents of the array list. So what I'm going to do is just return orders. Right? Now this is saying, whoa, bud, you need to return a string for your toString method. But what you're trying to return is orders. And if you recall, orders is ultimately a list. For us, it's an array list. And that didn't work. So what I want to do is take orders and call its toString method. Right? We're explicitly saying this. Now, another trick you could use is orders plus an empty string. And what this is going to do is force a call to the toString method, because anytime that you try to concatenate or add a string with something else, it's going to force a conversion to string. In this case, it's going to call the toString method. Now, while this doesn't look like a string, it is. It's a string with a length of 0. It's a string literal. So this is going to implicitly call the toString method, which is going to actually give us the contents of our array list. Here's the thing. This array list consists of cookie orders. Right? So when I go to run this, I get all these cookie order objects. Of note, there's 4 of them, because we did add 4 cookie orders. But now, instead of getting gibberish for the master order, I'm getting gibberish for these cookie orders. Cookie order needs a toString. Right. So I'm in cookie order. We're going to do public string toString. And all we're going to do is return the variety along with the number of boxes. And again, I'm just coming up with this off the top of my head to kind of visualize what's going on. Why don't we do something like variety along with, in parentheses, number of boxes. And so there we see chocolate chip 1. Maybe I would like a space there. The first cookie order is a chocolate chip, and there's 1 of those. Shortbread, there's 5, macaroon 3, and chocolate chip 3. So all I'm doing at this point is seeing what the contents of my master order is. So that's looking pretty good. And what I want to do now is count the total number of boxes. Now, what we should get is 1 plus 5 plus 3 plus 3. Right? 6, 9, 12. So why don't we print off our master dot get total number of boxes, which is what we were really coding for part A. And we see we get 12 total boxes. That's looking pretty good. Let's look at part B. The remove variety method updates the master order by removing all of the cookie orders in which the variety of cookie matches the parameter cookie var. The master order may contain 0 or more cookie orders with the same variety as cookie var. The method returns the total number of boxes removed from the master order. For example, so if this is what we got, right, and we go to execute, trying to get rid of chocolate chip, well, our chocolate chip orders are gone. And ultimately, we removed 1, 3, a total of 4 chocolate chip boxes. And so that's what actually gets returned. Notice this method has an integer return type. We're returning how many total number of boxes did we return or remove. Now, if we were trying to remove brownie, we're ultimately going to return a 0 because there are no brownie orders here. Okay, we're going to test this. All right, sorry, we're going to write this. So I'm back in my master order. So what I want to do is loop through our orders. With each iteration, I'm going to see, is the variety of the current cookie order equal to this one? If it is, remove it from the array list. But we also need to keep track of how many boxes. So the very first thing I'm going to do is create an integer, kind of like our previous method. Right? And as we remove boxes, we're going to add to this total. Okay? Now, let's try a couple of things. I'm going to, just like with the previous method, use a for each loop. Spoiler, we're going to have some problems here. With each iteration, I'm going to ask, is the variety of the current cookie order equal to the one that I'm looking for? Now, of note, we are comparing a string to a string So you want to use the equals method, not the equals relational operator. What am I saying? You don't want to do this. For this particular problem, it's not going to actually be an issue, but this is all going to be in an if statement, which is why this is mattering currently. Right? If the current cookie order's variety is equal to the one that I'm looking for, we're going to do something. Now, using an equals relational operator here is actually not going to be an issue. And if you did this on an FRQ, you shouldn't lose any points either because there's no ambiguity here. It is good practice, however, to use the equals method because what we're ultimately comparing is an object to an object, and we want to check them for equality, not to see if their pointers are referencing the same thing. So the current element is a cookie order. I'm going to pull out the variety, which is a string, and I want to know, is that string, what I've highlighted is a string, and I want to know, is that equivalent to this other string? If it is, I want to remove it. So I will take orders and remove the cookie order. Okay. If you notice, IntelliJ's highlighted this with a yellow. If we scroll over it, the loop could be replaced with, that's not what I was after. Ignore that. Okay. Another thing we're going to have to do is count the boxes that we're removing. So maybe before I remove it, right? So here I have found a cookie order that I want to remove. Before I remove it, let's see how many boxes are in the order and add that to our total box count. I'll take the current cookie order, get the number of boxes, right? So here I found a cookie order that I want to remove. I'm going to ask how many boxes are in that cookie order. I'm going to add it to this counter variable because on the very next line, we're going to remove it. And I pulled out the boxes. Yeah, I don't necessarily think it really matters here in terms of order because, I mean, the object already exists. But it kind of makes sense to me, right? Like, I want to count how many boxes are there before I get rid of it. Okay, at the very end, we're going to return our boxes. Now, we're going to try this out, and I'm telling you, there's going to be some problems. Okay. So, we already have example B kind of lined up. I'm going to take that master order, and I want to remove a variety, in this case, chocolate chip. And let's try that. I'm printing it because we should see a total number of boxes. This is actually returning something. And right away, this is the error that I was trying to somewhat warn you about. Concurrent modification exception. This occurs when you're using a for each loop and trying to modify the array list within that loop. Right here I have a for each loop, but within this loop, I'm trying to modify the array list. You can't do that. Okay? What this kind of lends to is you're going to need a for loop. So let's just remodel this. Right? I'm going to say we're going to switch to a for loop. So for I, I'm going to get rid of these braces. I starts at 0 as long as I is less than orders.size. That's our array list. This is a method. And to kind of make it easy, right, we see all these references to CO. Well, CO doesn't exist anymore. That was happening within our for each loop. What I'm going to do is just, first thing that happens with each iteration is I create a local variable called cookie order, CO, and it is equal to the current element. In this case, orders.getI. So I'm going to pull out the cookie order, save it into a local variable called CO, and what this really does is it means I don't have to update these things down here. That's looking pretty clean. Let's try it out. In total, what I'm actually going to see is just a number, which is the number of boxes that supposedly get removed, right? We're removing chocolate chip. So there's one box there. There's 3 boxes there. So that looks correct. But what I need to really see is, did those things get removed from my actual orders? And so after I recall remove variety, I want to see what does the order contain now. And yeah, they are getting removed. That looks pretty good, right? So there's a little trick here. What if the chocolate chips that we're trying to remove, what if they're back to back? That's the only thing I'm changing, right? So the original list is going to end up being chocolate chip, shortbread, macaroon. Exact same thing, except the order is slightly different. And we got a problem. This is one of the things you got to look out for, and this is both this is coming from the advantage that everyone perceives with ArrayList can be a disadvantage in certain situations. So what it is ArrayList have dynamic sizing. That is, whenever you remove an element, such as this first one, everything else is going to shift over to fill up that space. The problem is it's shifting over in the middle of the loop. Why don't we get an example going here? Right? Let's plug in, just right here as a comment. Here's our array list. Initially, I is at index 0. Why don't we kind of log I? Now, I doesn't actually exist at this point, but I is 0, so it's right here. We save it into CO. We're going to then ask, does the current cookie order, does the current cookie order variety, which is chocolate chip, equal to the one that I'm looking for, which is chocolate chip? Yeah. Okay. Well, we're going to pull out number of boxes, which is 1. Right? So this would then go to 1. We're then going to remove it. So I'm going to chop that off. And here's what's going to happen. Whenever we remove this element, these other things are going to shift over to close up that gap. Okay? Doesn't seem like a big deal. That's the end of the iteration. We come up here. We're going to do an I++. I then becomes 1. Now here's the thing. With I being 1, this is index 0. This is actually index 1. So we would then ask, is 1 less than our size? Well, our size is 3, so yeah. We'll pull out the current order, which is shortbread. We would then ask, is the variety shortbread equal to our chocolate chip? No, so nothing happens here. We would then do an I++. We're now at 2. We're here. We would pull that order out. We would ask, does macaroon equal to chocolate chip? No. We do an I++. I is now 3. We would ask, is 3 less than our size, which is 3? No, and we would stop there. So this is a problem with dynamic sizing. Now, there are issues with this, obviously, and there are several different ways to fix it. One approach is anytime we remove, we do an I-. That is the easiest change I can make to my current context. Right? What this is going to do is effectively offset the I++ that happens here, but notice I only do it whenever we remove an order. So let's try this. And we see that we are getting the correct response now. Right? So I do an I-, to offset the eventual I++ so that we kind of just remain in place. Now, the approach that I ultimately recommend, because I think it's actually the cleanest, I don't really like this. What I recommend is actually going in reverse. What do I mean? Let's start at this end and go towards the beginning. Okay, so we're going to modify our for loop header, and where we're starting is actually at the end, which is orders.size -1. Right? Initially, orders.size is 4, so -1 is 3. This is index 0, 0, 1, 2, 3. This is index 3. So we're going to start at size -1. Since we're going the other way, since we're going towards the beginning, we'll keep going as long as I is greater than or equal to 0. And we are going towards the beginning, so it's an I-. All I'm doing is going through the array list in reverse. I'm going to pull out the current order. Initially, that's going to be macaroon, and that's perfectly fine. I would then ask, is the variety equal to the one I'm looking for? We're going to pull out the number of boxes, and then we're going to remove it. Now, this is going to be a little bit awkward because I'm actually using an overloaded version of remove. And what this does is I'm removing an object, in this case, the cookie order. And so what it's going to end up doing is look for the first occurrence of a cookie order that matches this one, and then get rid of it. I think that's actually going to work here for us. Another approach that you could take is orders.remove I, which is the current element based on the index. Believe both of these are going to work for this particular problem. But all this allows me to do is get rid of the I minus minus. I no longer have to do that. Okay. Now, what this means is whenever we get rid of an element and then we like shift things over to close it up, it doesn't matter because I'm going the other direction. Right? We'll see that this works. Right, we're getting rid of our chocolate chips. Total of 4 boxes got removed. Let's look at an example as to, I'm sorry, let's like trace it to see what's going on here. So I'm going to bring back my original master order, right? We're ready to start looping. I, in this case, is actually going to start at 3, right? Our size is 4, minus 1 is 3. That's this index. Okay. We're going to ask, is 3 greater than or equal to 0? It is. We're going to pull out the current cookie order, which is macaroon. We're then going to ask, is the variety macaroon equal to the one that I'm looking for? Does macaroon, let's put it in quotes, equal chocolate chip? In this case, no. So nothing happens. We then do an I minus minus. I is now 2. That's going to put us here. We're going to ask, is 2 greater than or equal to 0? It is. We're going to pull out the current order, which is shortbread at 5. We're then going to ask, does shortbread equal chocolate chip? No. We're going to do an I minus minus, which puts us at index 1. That's this element here. We would ask, is 1 greater than or equal to 0? It is. So we're going to save in chocolate chip here. We would ask, does chocolate chip equal chocolate chip? Yes. We're going to pull out the number of boxes. In this case, it is 3. So this would then go to 3. And then we're going to remove the current element, right? I'm going to get rid of this guy. And what's going to happen is the array list is going to shift over to close up that gap. Okay. That's the end of the iteration. We would do an I minus minus. We're now at index 0. So notice that the shifting over doesn't matter. I've already moved on. We're on this element now. We would ask, is 0 greater than or equal to 0? It is. Notice the equals allows us to actually get this one. We would pull it out, save it into a local variable. We would ask, does chocolate chip equal chocolate chip? It does. We're going to pull out the number of boxes, which is 1. We're going to add it to our current boxes, making this 4. We then remove the current element, which is chocolate chip, this boy right here. All that stuff's going to shift over to close up that gap. We do an I minus minus. I is now negative 1. We would ask, is negative 1 greater than or equal to 0? It is not. That's it. Okay. So the big takeaways here are being careful with this, right? Because if we just used the example that they gave us, it looks like everything was going to be hunky-dory. But there's an actual problem that they're not really testing you in the example on, and that is, what if the orders, the varieties, are back-to-back? Here we saw an issue by going through our own example, and we fixed it. And there's a couple of ways to fix it. Again, ultimately what I like is going in reverse, because it is ultimately the cleanest. That like extraneous I minus minus, which is a little wonky that was down here, we got rid of that. But that being said, doing the I minus minus that would work. Like that, you would get credit for that. So we're going to wrap it up there. Let's chill.